Hey, this is Josh, and today I wanted to go over simple interest and compound interest. I wrote both of the formulas up here on this board just so that you had them as a point of reference, but I'm going to work on them separately and we'll throw in some numbers as well. So the first here is for basic interest. Some books call it simple interest, and I guess I'll go with simple interest, okay? But interest equals PRT. Let's label all this stuff just so we kind of know what we're working with here. So we have the interest is equal to the principal, and we could even say the starting amount. Okay, so like the amount that you start off your bank account with or whatever it is you're doing. And then we have the rate, and we could even be more specific and say the interest rate. And then we have the amount of time. Yes, there is that. And that's the time, okay? And simple interest is very straightforward. We're gonna figure out the total amount of interest we've earned based on how much you start with times the rate that you're being given and multiplying that by, well, how much time did you invest? And so let me just throw in some values, okay? Let's say you started off with $400 and we're being given 5% interest for 6 years, let's say, okay? Well, let's plug all these into this thing, okay? And this is why I kind of like having these labeled. I think it's gonna help me get all this into this problem. 400 is gonna be the principal amount or the starting amount. So we start off here with, I guess I should use some of these colors. We have 400 times, or you could do it like that too, times 5%. Now be careful with these percents, okay? Remember, it's just not a 5. If I throw a 5 right here, right? Now I'm doing 400 times 5. I'm gonna get some super big number. And you should look at it and say, you know what? There's no way I'm gonna be making that much cash on 5% interest. So just remember, you need to convert this to a decimal number or a decimal value. 5% is the same thing as 5 out of 100. Or you could read your fraction down, 5 divided by 100. It's gonna give you a 0.05. Okay, and then the last part is your time. And what this is gonna give you, this doesn't give you your final answer. Now it depends on what the question is asking. Is the question asking how much interest did you earn, or what is your balance in your bank account after the 6 years? If you're just searching for the amount of interest, you just crank through this guy, multiply all this stuff out, and see what you get. So we have 400 times 0.05 times 6, which is, let's see here, 120. Okay, let me just get all this stuff out of the way. Okay, so this times this times this gives me 120, and it is in dollars. So I have $120 in interest that I earned. And then if the question says, okay, so that's if the question just says, how much interest did you make given these parameters? And then if you need to take it to the next step and say, well, what is the balance in your account after 6 years? Well, we had $400 that we started with, and now we have an extra $120. So my total balance in my checking account or whatever account would be 400 plus the 120 to give me $520. Put in the dollar sign, remember, units. So that would be my final answer. All right. Let me erase all of this and add a little twist to this, because for the most part, it's pretty straightforward. When it gets crazy is when they start doing stuff like this to you. So let's use the same amounts. We'll say we have $400 to invest at 5%. But now rather than using full years, they're going to say, oh, well, how much would you have earned in 3 months? Huh, okay. Well, I know the first parts of my equation that I'm going to be creating here. I know I have my 400. I know I have my 0.05. But this guy, I can't put in a 3 because this time here is being calculated in years. And so I need to convert my years into months. So there's a couple ways you can do it. I go with the quickest, most efficient way and look at it this way. All right, well, we know it's 3 months out of 12 months. So I can just move this right into the next spot right there. Or I could even go so far as to, that blue is kind of done. I could even go so far as to take it to the next step and reduce the fraction into 1/4. Either way, it's gonna work. It's just that I'm working with a smaller number. And I could multiply this by 1/4, which in my head is a little easier to convert. 1/4 is the same thing as 0.25, right? 1/4 of $1 is 25 cents, 0.25, okay? So I have my 0.25 times 0.05 times 400. I don't know why I'm turning things towards you. You can't read it. Well, maybe you can. Gives me 5. Okay, so after all that work, I end up with 5, right? Well, that's the amount of dollars that I would earn in 3 months. So just remember, if you're given time in years, you just plug it right in. But if you need to find a segment, then you need to make it into a fraction. Reduce it if you can, but even if you didn't, I mean, you could still use this right here. Read your fraction down, make it into a decimal, and then multiply it by the next 2 parts. And you'll still end up with 5. So the interest would be $5 in 3 months, or if it said, what is your balance after 3 months, given these 3 things? Well, you would just take your initial amount, 400, add 5 to it, and say my final dollar amount would be $405. And you're all set. So we went through it once using a full amount of years, 6, and then we did it with a portion of a year as well. I want to do the same thing with the compound interest equation. So let me get this out of the way. Yeah, we don't need this anymore. So that can all be gone. And I'm just going to rewrite this equation here. The nice part about the compound interest is it's going to give you the big B here, the final balance. So there's no like adding stuff together at the end, which is kind of nice, right? The less you can do or have to do, the better. Okay, let's see here. We'll say we start off with $1,000. $1,000. We'll say 6% interest again, and we'll say 5 years. Okay, well, I guess we should go through the equation and label all this stuff. So B, it's a capital B, is the final balance. Okay, P, just like in this equation, is the principal. Principal or starting amount, that's just a number 1. And then we have R, which is the interest rate, and then N is the number of years. Okay, and so yeah, looks like we're in good shape. So let's crank this stuff out. Let's plug it all in. We have our principal amount. We have 1,000 times 1 plus 6%. Be careful, it's not a 6, it's a 0.06. And then how many years? 5. Hopefully you're asking, why is that 1 there, Josh? Like, why would you put a 1 in there? And the quickest way to explain it is this. If I just had a 0.06 in here, and I went to the fifth, if I did 0.06 to the fifth, or if I did 1,000 times 0.06, I'm multiplying by a decimal. And what's going to happen is this number is going to get smaller, not bigger. So by adding a 1, what I'm doing is I'm now creating a 1.06. So if I multiply this times like 4, let's say, all right, if I were to do that and do 4 times 1.06, I'm going to multiply 4 times 1 and 4 times 0.06, which is going to give me a bigger number. Or I guess you could just put it in your calculator. 4 times 1.06 is going to give you a much bigger number. The 1 there is making you multiply it so that the 4 not only just gets smaller, but actually it retains the amount or the value of 4 and then goes farther and adds more to it. If you didn't have the 1 there, you would be working with smaller and smaller and smaller numbers, especially if you were using exponents like this. So I hope that made sense. It does get kind of complicated, and as you get farther into math, you talk more about like why the 1 is needed in there. You start to see this again when it comes to like exponential growth and decay. You see that same value showing up. Let's see here. Well, it's in the equation. Let's see. So we have 1,000 and we have 1.06 to the fifth. Order of operations, okay? So it's 1.06 to the fifth. You got to do this guy first. Order of operations. Parentheses, you can't do anything else. Exponents, we do have that. If you don't have a fancy schmancy calculator, you just do 1.06 times 1.06 times 1.06 times 1.06 times 1.06. Was that 5 of them? I hope so. That's what you got to do, okay? And if your calculator can't even handle that, you do 1.06 times 1.06 equals, write down your answer. Do it again, and then multiply that by 1.06 one more time. Let's see here. 1.06 times, I'll do it the old-fashioned way. 1.06 times 1.06 times 1.06 times 1.06 is, it's just some long repeating decimal. 1.338, some 22, and it just goes on. So I'll just say 1.3. 1.3 times 1,000, right? Because we got to keep working through this thing. So times 1,000 is 1,338 is about $1,338. It is in dollars. So we'll say that the final balance after 5 years at 6% being compounded annually would be around $1,338. And you can be approximate, right? Yeah, there's some change in there. You could round it up or round it down. But getting through it to this level shows that you understand the equation and you're able to apply it to the problem that you're given. Okay, now this is annual interest, but then sometimes you're asked, well, what about semi-annually or quarterly? Okay, it gets back to that first one that we did over here. When time is in years, you just plug it right into the equation. But if time is like, well, what about every 3 months? You got to make that fraction. Same thing with this. So let me erase all of this. $1,000, 6%. We'll do 5 years. And rather than the interest being compounded annually, we will say for this guy, it's compounded semi-annually. Annually? 2 N's? I think so. I don't know. I can't remember that. I always mess that one up. Let me double check here just so I'm writing this stuff correctly. Let's see here. Yeah, 2 N's, 2 L's. Okay. You got to make sure some of this stuff is right. Let's see here. $1,000. Okay, so that just goes into the equation. We have our 1 plus R. I'm going to hold off on that for a second, and then it's 5 years. That doesn't change. but the semi-annually is going to affect your interest rate, okay? The interest rate on this guy was 6%. Semi-annually means you're going to do it twice within the year. So what you do is you take your 6% and you divide it by 2 because you want semi-annually. If it was annually, it would be 6%. If it's semi-annually, it would be, well, you divide that in half. So you end up with, instead of 6%, you end up with 3%. Or if we write it in decimals, 0.03. If it was quarterly, you would divide the 6% by fourths, okay? So it just depends on what they're looking for you to do. This one was semi-annually or twice a year, so we divided it by 2. If it was quarterly, you would divide your interest rate by 4. It does affect how much you make. So let's see what happens. 1 plus 0.03 is 1.03, and that's to the 5th. So let's do the same thing here. I'm going to go old school and just do 1.03 times 1.03 times 1.03 times 1.03 times 1.03. I know that's probably not the most efficient method, but I just want to show you that it can be done that way. I don't think that you need to learn all these tips and tricks and go crazy with some of this stuff. You can be very practical about it. And so if this is the best way for you, then do it. If you have some fancy schmancy that has the up arrow and lets you put in the exponent and push equals, then use that. But it's really, work with what you have. And I'm here to show you that you don't need much, okay? So that ends up being 1.159. I'll just say 1.16, okay? So I have 1,000 times 1.16, which is going to be about 11. It's just moving the decimal over, actually. So it's going to be about $1160, okay? And remember, when you do this, you're coming up with the balance, okay? Actually, it is squiggly equals. You're coming up with the balance on these problems, okay? You're coming up with the final balance. You don't have to add this amount to your original amount, because if you did, think about what you'd get. You'd get $1,000 plus another $1,160. Man, I'd love to work at shop at a bank like that, or invest in a bank like that, where you're doubling your money, every 6 months. That's not going to happen. So just remember, with the capital B, that's telling you that this is the final balance, okay? With your simple interest, you're just getting the interest that you've earned in that time and adding it. But with the compound interest equation, you're actually coming up with your final balance. So thanks for watching. Subscribe to my channel. Check out my other videos. Let's get through this stuff together.